थोड़ा टाइम लगेगा, 5 मिनट ना, डायरेक्ट शुरू कर दें। ये मोबाइल भी स्विच ऑफ कर, साइलेंट कर लेते हैं। बहुत एक कॉल कर रहे हैं, वो हॉस्टल वाले ना, तो अभी उनको जरूरी है।
पेजेस है, अभी एक लगा दिया वन, अभी एक पेज लगा है।
ओके,
तो ये और पेजेस हैं और उसके अंदर रखे हैं। आई थिंक वो इतना जरूरत नहीं पड़ेगा, तो ये वाला फिल हो जाए तो आप फिर नेक्स्ट लगाओ।
इसका तो जरूरत नहीं है, ठीक है।
ओके सर, तो स्टार्ट करते हैं।
एडमिट ऑन कर दीजिए। माइक थोड़ा ऑफ कर सकते हैं कुछ टाइम। जो डेफिनेशन है दिस वन वी हैव टू एक्सप्लेन अगेन, जो रिकवरी है वो वाला रिकवरी है वो वाला जो है ना, उसको डिस्कशन करना पड़ेगा।
I sent you these questions also up to this. रिकवरी वाला, रिकवरी रिमूवल वाला।
नहीं, अभी लैपटॉप लेने से भी दिक्कत है ना, अभी एक्सप्लेन करने आधा घंटा तो लगेगा।
एक बार आप सर बोल दीजिए अपना इंट्रोडक्शन ना, कि जो भी आपका क्वेरी है वो आप टाइप करके पूछ सकते हैं मैसेज में।
बहुत
ये तो आते रहेंगे सर। काफ़ी बच्चे हैं,
काफ़ी बच्चे हैं ना,
इंटरेस्टेड हैं।
मेरा लगता है।
ठीक है सर, माइक को है ना,
हाँ,
आप बोल दीजिए कि जो भी क्वेरी है ना, फिर आप मैसेज खोल लीजिए ना, वहीं पर ही टाइपिंग सर लिखते रहेंगे बच्चे ना क्वेरीज।
थोड़ा पानी पी।
ठीक है,
इसको बोलना। Hello everyone, welcome to this live session, first live session on VLSI physical design with timing analysis, and you can ask your questions in the chat message. We can answer one by one. Is there any questions? Okay. So we'll start one. So you can ask your queries in the chat message, and we'll answer one by one. So hello everyone, I am audible to everyone?
Good evening, sir. Yes.
Hello.
Good
Yes,
evening, sir.
audible, audible.
Audible,
Yes,
sir.
yes, okay. This is not needed. Okay. So can you explain what is that? Just one minute. Okay. So we'll start from this one. Or this one is needed.
कोई टाइप कर रहा है, टाइप से कर।
Hello. So hello. Yeah, so there are some questions. Can you explain pre-STA and post-STA practically? So, what is the meaning of pre-STA? Means what I understand is that before parasitic extraction, the STA, and after taking the interconnect into account, then you can do the STA. That will be the post. Okay, so but I have not gone through any particular term like pre-STA, post-STA somewhere, but in my view, pre-STA is basically a estimate of whatever the timing you are getting. But post-STA means after taking into the parasitics, buffer delay of the CTA after the clock tree synthesis, all these into account, what you get, that is the more accurate value of timing what you got. So, Pavan asked, can you explain the similar question related to assignment 5? We don't know exactly which assignment 5. Can you please elaborate? Then we can able to answer. Then the next question is Ranjit, what is the physical design in VLSI? Why it is needed? Ranjit, the VLSI physical design means that let's say if you have designing some circuit in Verilog or any kind of hardware description language, like any means not only Verilog, VHDL or system Verilog or any language, then you can convert to that to a complete layout, because the layout is the thing which is accepted by the foundry. So you write in some kind of programming language like hardware description language, but the physical design is the how to convert that Verilog description to a layout. Why do you need a layout? Because the foundry accepts the GDS of your design, means layout of your design. We cannot basically the foundry only can accept the layout, not the your behavioral description what is there in the Verilog. So that is the reason we in this the complete transformation from the RTL to the layout level or the GDS level thing covers in physical design. So it consists of two parts. One is called logic synthesis and physical synthesis, what I explained in one of the lectures. Okay. So then, basically, then the next question is what is it? Ramkoti asked, what is the difference? Can you please go up? What is the difference between DTA and STA? Dynamic timing analysis and static timing analysis. In case of static timing analysis, basically we are not considering the input vector. In case of dynamic timing analysis, we are considering the input vector. Next, can you please go up? Can you please? Amrita asked actually the question. Can you please explain the gain calculation in FM algorithm? Okay, so basically, as far I remember, it is basically you should have a gain factor. It consists of two things minus something na exact thing
is equals to fs of E minus
what is that
delta G of C is equals to
delta G of C is equals to
fs of C minus
fs of C minus
fs of C minus
okay
C
T of C na
okay T of C
again I have to write
Yes.
huh?
Yes.
Again I,
Yes.
T of C. Okay, so fs of C and T of C are explained in the lecture. You can go through that. Okay, and then the next question is that Saket in OCB analysis, how direct margins are chosen, means for I think setup and hold, how we came to choose a particular value. Okay, so in case of OCB analysis, I did three types of analysis. One is called without variation, then with OCB, OCB plus CRPR. Okay, just a minute. Yeah, so this is related to the basically gain of a FM algorithm. Okay, so basically there we need to in case of OCP analysis we need to take the direct value, and direct value will depend upon what type of analysis we are doing, whether we are doing the setup check or a hold check. Okay, so please go through that example, and if you have any particular question, please ask in the discussion forum. We will reply. Then basically next one, what is the next question? Yeah, Farooq Patel, why gate should not be open in the design? What are the effects it will cause? Okay, it means which basically the transistor gate should not be open in the design. Basically, what I understood is that you have a transistor, that gate should not be driven. It should should not be open, because if it will be open, it can catch any signal and your output behavior will be not deterministic. So we want deterministic behavior of your CMOS logic. So we should not open the gate terminal. Why? Compared to front-end design engineer, like so Prem asked this question actually. Why compared to front-end engineer like RTL, more jobs are posting related to physical design? Can you say? Okay, so basically the reason is that in case of physical design, it have number of steps are there. Okay, so you have basically partitioning, floor planning, placement. Then we have clock tree synthesis. In before the clock tree synthesis, you need to do the power and ground routing. Then all these steps requires a huge amount of manpower, and also the RTL, once it is done, then we need from across process. When you go from one technology node to the other technology node, you don't need to design the RTL. But the physical design need to be done for each technology node. So that's the reason you have more jobs related to physical design. How to remember all the concepts related to physical design with STA? I guess this is Taib Ahmad. This is a good question. How to remember all the concepts related to physical design with STA? In my view, you should not remember any formula. I also don't remember any formula, but try to analyze things, because if you analyze all the concept, then only it will be automatically in your brain. That's the reason I taught by writing this STA. So always try to consider the worst case condition. So if you can understand the worst case condition for the STA, then your understanding for the static timing analysis will be better. So then Ranjit Kulkarni, can you use cadence tool to do physical design? So cadence is one set of tools which you can use for physical design if you have the cadence license. Similarly, Synopsys has a set of tools for the physical design, so you can use any one of them. But it is not the cadence virtuoso tool. It has Innovus and Janus. Janus is basically used for logic synthesis, and Innovus is used for physical synthesis. So that is from the cadence side. Similarly, from the Synopsys side, we have logic synthesis tool called design compiler, and for physical synthesis we have IC compiler. Okay, so then next question is by Narendra. is you can use cadence tool or synopsis tool for, okay, he has answered that. Does open source tools for simulation used in industry? If no, then how different is open source tools compared to those like cadence? No, cadence, but don't confuse that. We use whenever we are using physical design, we are using cadence virtuoso. Cadence has another set of tools called Genus and Innovus. Those are used for logic synthesis and physical synthesis. Logic synthesis and physical synthesis. And your question is related to basically these open source tools may be used in some startup company. I don't know. I cannot comment. But these open source tools are free to use. But this cadence and synopsis tools are, you have to pay money to get the licenses. So Mohammed Atif, what is structural testing? How can we say that structural testing with fault give more accurate testing results? So it is related to testing, so I don't want to cover it here actually. Okay, so it is testing and verification. Okay, so then the next question is related to, what is that, Rishikesh, whether the course includes physical verification including DRC process antenna connectivity. So we have discussed some part of it related to antenna rules and how to fix that in week number I guess 11, week 11, wherever we discussed about the standard cells and what are the cells there in case of a standard cell library. So you can go to the 11th week when it will come, and then you can learn this antenna, how to fix the antenna violation. Then Prem, is full custom design style is flexible or complex? So it is, if you have a less number of transistors, then full custom design is flexible. If your number of transistors increases, then the full custom design style is very complex. Usually the analog designs are done using full custom design style because they don't try to automate things. Then Bhamsi is asking why hold is not taken into consideration up to CTS. Can you please explain it briefly? Why hold is not taken into consideration up to CTS? Can you please, why hold violation is not considered in CTS? Up to CTS, because maybe the reason I may say that the buffers are not inserted. That is the reason. In case of CTS, after you do the CTS, your buffer tree is created. So usually you need to look after the buffers are inserted. That may be one of the reasons. Assignment 5 is Pavan asking this question. The assignment 5 is about floor planning algorithm and representation. So can you please write the question? Pavan, you can write the question in the chat. The Agnivesh is asking, can you please explain linear ordering algorithm in floor planning? So see, actually at present explaining any algorithm will be difficult. If you have any particular question related to that algorithm, it will help, or you can ask this any particular part of it in the discussion forum. We'll happy to reply to your queries actually. So then please Chiluka is asking, please explain the simulated annealing algorithm. The simulated annealing, whatever I remember right now, is basically it is a heuristic driven algorithm based on the annealing process. When your temperature is very high, then accepting a solution state is higher. When the temperature is low, the accepting a solution is low, because your optimization function is come closer to the minimum or optimal point when your temperature is high. That's the reason, that is the main purpose of simulated annealing. Bhamsi is asking, can you please explain power placement grid, manufacturing grid and routing grid? Okay, so so basically this is a very interesting question. I have not covered in any of the lectures. So the placement grid will be the based on the grid of the placement grid will be larger. Okay, because it depends upon the basically the standard cells or the block size you want to place it. The routing grid is defined by the basically routing grid width of your metal. In one of the technology file it was written routing grid, and the manufacturing grid is related to what is the minimum size you can print, and based on that you can define the routing grid and the placement grid. So manufacturing grid is the smallest one, and the routing grid is the related to your metals, M1 to any higher level metals like M8 or M9. So that grid is defined in one file in a whenever you are doing the physical synthesis, and the placement grid will be defined by the your standard cell width, and there's a called unit tile. Okay, in the technology file. Okay, as you say, Narendra is asking, as you said, for setup in launch path we apply late directs, in capture path we apply early direct. For hold it is vice versa. Correct. So how we decide that for a launch path some 1.1 and capture path is 0.85. So how do you decide that value? Okay, that's a very interesting question. In my example, in that example I have taken the direct late is 1.1 and direct early is 0.85. It is a assumption in this case. However, every process they have a estimate that comes from the foundry, or if you have a some kind of experience with the on chip amount variation, how much it is happening, so based on that you can choose that value. So if it comes from the measured data from the silicon actually, because it is on chip variation in the same chip. Okay, what is the worst case variation, and based on that we can find out this value. Okay, so Pavan is asking, can you please explain the KL algorithm? So it will be difficult. We have a short time, so please ask any particular question to the KL algorithm. But we'll be happy to reply in the discussion forum. Correct. Then Chiluka is asking how to determine continuing nets and terminating net during iteration. Okay, so this is related to linear ordering algorithm, whatever I remember. So it is basically whenever you have a any iteration is going on, you try to place the next block after that one, then you see what are the continuing nets which is going away from that block, that will be continuing nets, and which is terminating in that block, those are considered as the terminating net. Terminating means that, let's say I have a block here, you can see at the screen. Okay, and let's say this is block A and there's a block B. Okay, I'll drawing it again. Let's say this is a block A, this is the block B. So let's say one net N1 is going like this and ends here. Okay, so this is my basically, is it visible? Is it visible? No? Okay, this is my terminating net. And let's say I have a net N2 which is going like this and going like this. Let's say this is N2, it is a continuing net. Net if the block B sits after A. Okay, if you place the block B after A, then N2 is my continuing net and N1 is my terminating net. Okay. So next, can you remove that line? Saurya is asking, I know of on-chip variation. Are there any off-chip variation? I could not find this concept online. Okay. So this is basically whatever I explained in the lecture is related to on-chip variation. Then the off-chip variation is related to across corner. Across corner means we have multiple corners the chip can go through. In industrial design, we have, let's say, around hundreds of corners. But in what people do is that they want to simulate your design across different corner files. Basically, let's say you have a fast corner, then you have a slow corner, then FS, SF, like that. So for fold violation we need to simulate at FF corner, and for setup violation you need to simulate at SS corner, because SS means slow. So
What is slicing algorithm?
just 1 minute. Yeah. Pawan is asking one question: what is slicing algorithm? It is related to, I think you are talking about slicing tree. Can you please elaborate? Because we have talking about if you have a floor plan, we can represent that floor plan using a slicing tree. So the process of slicing tree formation is explained in the lecture. If you have any particular question, please ask. We can reply in the discussion forum. Chiluka is asking, please kindly would you upload the recorded session? Yes, I think this recorded session will be uploaded in the YouTube. Okay. Then Narendra is asking why hold is not taken into consideration up to CTS. Can you please explain if it briefly answer up to CTS? The clock is ideal. We use what is that, WLM
Model.
wavelength model to estimate the RC parasitics. So before CTS the clock is not real. So after CTS clock tree is building, we will consider hold. Yes, that whatever you are telling is the same thing what I explained in words. Actually that's a good whenever we have not done the CTS, basically our wavelength is just a estimate, it is not accurate. So after CTS actually we need to consider the hold violation. So
Sir, wire load when we are using,
what is that?
like which stage we are using wire load model?
That wire load model, whenever you are doing this, there are two places. It is used every places based on your requirement. Let's say if you are doing routing, whenever you are doing the routing, actually, you have a different global routing is already uploaded. No, it is not uploaded actually. So there are 10 different wire load models are there actually. Okay, so we have explained in the global routing stage actually. So how to estimate your routes? Okay, so there are 10 different methods are there to calculate the interconnect distance. Some are will be very fast.
Placement में है sir. Wire length estimation. Placement में.
Now it is already I think it is already there. So the placement, in the placement also, whenever you are placing a block, we need to estimate the wire length. So there are a different method to estimate the wire length. So based on the requirement, let's say I want to go for a very accurate estimate of the wire length. It will take more time. There is a half perimeter method which is giving very less time, but it is not accurate. So that's the half perimeter method is applied. So your question is at which phase it is applied? It is applied in placement, it is applied in clock tree synthesis, everywhere you need wire length estimation. It is very, very important. Why you need wire length estimation in every stage? Because I want to reduce my wire length every stage of your physical design. If I increase the wire length, then what will happen is that your interconnect delay will increase, your performance will suffer. And the second point is that in case of CTS, we are not reducing or we are not increasing it, we are trying to balance the wavelength such that my zero skew will be achieved actually. Okay, so in the next week we are uploading the CTS lecture, that clock tree synthesis. Their interconnect estimation is very essential. Then Rasmita is asking which books should I follow for VLSI design. Okay, so in our NPTEL lecture, basically in that one we have given some of the books. One is Sherwani, one is the
design or physical design?
VLSI design or VLSI physical design. So since this course is related to VLSI physical design, I am telling some of the books related to VLSI physical design. And one of the most popular book is basically Sherwani and Khan. So this is related to VLSI physical design. And for timing, one book is called J. Bhaskar, that is good book, and another book by Sachin Sapatnikar, that is also a very good book. But what I suggest you, please go through the lectures, whatever I taught. I try to give some examples to each of the timing questions. So try to do those practice questions, practice these questions very well, so that your concept on STA will be improved actually. So next question is Chiluka is asking what is the difference between slicing and non-slicing floor plan actually. So in case of slicing floor plan, we are cutting that complete bounding box into two different partitions. Okay, and in case of non-slicing floor plan, it will create a it will not cut the bounding box into two different partitions. Okay, so that is the difference between a slicing and non-slicing floor plan. So then Narottam is asking how do we say floor planning is a good floor planning? Okay, that's a very good question. Whenever you are doing the floor planning, basically if your total area of the bounding box is minimum, and your that is the first goal, area should be minimum, that is the first goal of any floor plan. And the second okay, in the second point is that your wire length between the interconnect should be minimum, but the area is the first goal for okay. So basically area is one of the most important whenever you are going for a floor planning. What is the next question?
One
This one. What is it? Mohammed Atif is asking what is blockage, what is the user blockage, at what what is blockage, what is use of blockage, and at what stage blockage is decided. Okay. It is not covered, but I can answer. So blockage is related to, let's say, whenever I design standard cells, let's say. So the standard cell contains M1 layers actually, metal 1 layers. So whenever we do the routing in the top level between the standard cell, there is a blockage of M1, there is a blockage of metal 1. So that the tool will not route over the standard cell in metal 1. So that is for a standard cell case. But whenever you have a blocks, let's say I have a block, one piece of block, let's say this is my can I share?
1 second. New bed.
Yeah, just 1 minute. So let's say this is the chip.
1 second, sir. Share.
So let's say this is the chip, okay, and I am placing a block here, okay, and the block, inside the block I have, let's say this block 1 it uses still metal 3, okay. So the tool will create a blockage till metal 3. Why? Because if the block 1 is using till metal 3, so the physical synthesis tool should not route anything above it. If it is routing, what will happen? It will create a short, and the short will create a LVS error, and it is not desired actually. So what it was done is that when the block 1 is created, then the blockage till metal 3 is defined by the physical synthesis tool itself, okay. Next, what is that actually? What is the question?
Anshul has some.
No, okay. Vansi asked, in optimization process, we can go for VT swapping. So by VT swapping, the can cell area increase or decrease or remain constant. So actually, this is not taught, but I can answer this question. So yeah, whenever you are doing, basically there are various types of libraries are there. So we have LVT, you have SVT, then we have HVT, okay. So whenever we have this type of libraries are there, let's say I have a critical path where I need higher performance, I should use low VT cells actually. So since you use low VT cells, my delay will be less, my performance will improve. So that is the idea. But whenever you are changing the VT of a cell, it will not increase the area, but thing is that we need to choose it carefully whenever we have a particular design and we want to improve the performance of that design. Then comes Devi is asking why standard cells are placed in M1 layer. Okay, that's a very good question. Since let's say if M1 is the only layer, is the first fast metal available, and if I create my standard cell in metal 1, then I have M2 to other layers are used, M2 to M4 can be used for routing between the standard cells or among the standard cells. But if I use M2 in the standard cell, then M2 will be blocked for routing. So that is not a good idea. My routing resources will be reduced. So that is the reason the standard cells are placed in or designed in metal 1. I think the question should be placed instead of placed, it should be designed actually. Why the standard cells are designed using M1 layers? That's a very good question. Can you explain, Kiran is asking, can you explain about 2D and 3D cell delay in LUT model? What is this 2D and 3D cell delay in LUT model? Can you please clarify this question? I am not sure about this, so I am not, I cannot answer. Okay, then Nala Pallavi is asking, can you please explain the linear ordering using an example? The example you explained in the lecture is bit confusing. We can answer, or you can do some different example if possible in a discussion forum, or you can tell us which is the confusing part. We'll explain that in the discussion forum. Okay, so if you have problem in finding the continuing net or this terminating net, whatever I explained, please ask in a discussion forum, we will reply. Kiran is asking, can you explain about multi-clock domain? Okay, so we have not covered this here in this physical design, but multi-clock domain, the setup and hold check will be completely slightly different, not much different, but slightly different compared to the single clock domain based timing analysis. So, Naveen asked how to determine the quality of power grid. This is very, very important questions. Basically, whenever you design a power grid, most important point is that how much IR drop is happening in the design. So the IR drop, whatever it is happening, that need to be taken into account. That much means if it is good enough to get your performance in the end point. So, whenever you do the power grid design, you need to check that how much drop is there, and based on that, you can make the design quality of the power grid better. Okay. So the next question is Nalla Pallavi is asking, can you please explain slicing and non-slicing floor plan with an example? So whatever I explained earlier also, just let's say I have a I'm drawing here. So let's say I have this is my bounding box. Let's say I'll do a complete cut. The left side is, let's say, one partition, and right side is another partition. So it is cutting the complete bounding box into two parts. Okay. So let's say this is A and this is B. Okay. So this is a slicing floor plan. But if I do like this, if I have a bounding box like this, then let's say this goes like this. Okay, let's say this is A, this is B, this is C, this is D, this is E.
It is a slicing clock like that.
No, because it is not cutting actually, no?
Actually,
Wheel.
you can, no, it's not a wheel. You can cut this here, right?
Okay, okay.
And after that, you can cut this. Actually, wheel would be like C should come. No, it's a different.
So it will not cut into two parts actually. Okay. So here if you can see, let's say I'll erase this portion actually. Let's say this portion I'll erase. Okay. So you have that PPT. If you can go to the slides actually, I don't remember the lecture number. Okay. So here whenever you have, just I'll draw the non-slicing floor plan. This is a slicing which is cutting your bounding box into two parts. This is a slicing floor plan. Okay, I am drawing, this is not correct actually. I am drawing the non-slicing floor plan. Okay, so it is not cutting your complete bounding box. This is your bounding box, this boundary into two parts. Okay, so this is called your non-slicing floor plan. This is non-slicing floor plan. Okay, so now basically Rasmita is asking, the Kale algorithm after fixed the nodes in the first pass, how to draw cut net for the second pass? Can you please explain? So Kale algorithm after the fixed the node in the first pass. Let's say I did a one pass, then I will how to draw the cut net on for the second pass. The output of the first pass will be the input for the second pass, first iteration of the second pass. Then again we'll do basically then you can do the Kale repeatedly on that one. Then that process will be repeated. Kiran is asking, can you please explain about late phase shift and early phase shift related to clock? I think so, or which one? Let what is the? Can you please elaborate this question, Kiran? Then Dosapati Krishna Kumar, can you please explain how to decide the standard cell height and metals to use? This very good question. Can you please explain how to decide the standard cell height and metals is already I explained the metal one. Obviously, the height of the cell will depend upon basically how many metal tracks you need. Okay, so let's say this is basically your one metal. Okay, this is metal 1. Okay, there is another metal, let's say the same metal 1. Okay, so this is also M1. Middle of this one to middle of this one is called the metal 1 pitch. Okay, this is metal 1 pitch. So what is the point here is that how many multiple of that one you can need to design your standard cells. Some cases is 9. So this is one metal 1. This is another metal 1. This is one metal 1. This is another metal 1. So whenever you are designing any standard cell, so this M1 is your basically VSS line and the lower one, and you can do the top one. Two tracks are gone for the power, and basically rest of the things we are using for NMOS and PMOS. Okay, so this is the then the height of the cell will depend upon 9 track or 10 track or 7 track, depending upon how much you want to, how much performance you want, how much power requirement. All these taken into account to design the height of the cell. But the basic principle is depends upon the number of tracks actually. So then you have Musharraf Mohammed. Can you please discuss some project ideas for this particular course? There are various project is there, but you can do any design and write it in the RTL domain and do the complete logic synthesis and physical synthesis, and then you can check whether your design is meeting the required specification or not. You can take a FIFO design, you can use a UART, SPI, those are the very simpler one, or you can go for a processor design where you can go for a RISC-V processor architecture to be implemented in case of a layout version. So from the RTL to GDS you can design it. So 1 minute break little bit. So now Nalla Pallavi is asking how can we differentiate between continuing and terminating net when a net start at block A and has connection at block C and ended at block D. The sequence of block A, B, C, D. Would you please explain the nets? We need to draw it actually. Okay. Can you draw and ask in the discussion forum? We'll definitely reply to your question. Okay. So because of time, I am not spending here. So please draw the diagram and send in the discussion forum. Exactly, we can explain you through reply. Okay. So what is the difference between open lane and open road? Open road is a basically a physical synthesis tool, which is open source tool. We'll discuss in the basically 12th week. We have a demo version of the open road and open lane. I don't know actually, but it may be some version or some other tool. I don't know. So then Prasad is asking height. Okay, sir, height okay, but how can you determine the standard cell width? That's pretty interesting questions. But the width of the width will be determined by, there is a concept called unit tile in the standard cell, the unit tile in the technology file. So based on the unit tile, the width of your standard cell will be determined. So it will be the multiple of the unit tile. Your width of your standard cell will be the multiple of the unit tile. Okay. So and there is some basically concept is there. So what is the poly? Let's say your inverter is there, it will be 3 unit tile or something like that. Okay, so if you have more poly will be there, one unit tile will be added. Okay, so now Kiran is asking early phase, late phase shift in launch and clock age. Early phase late, early phase late,
early phase, late phase.
early phase late phase shift in, okay, early phase and late phase shift in the launch and capture clock age. Okay, so you have a so whenever I did on chip variation explanation, so for a setup calculation, okay, so what we did is that for worst case setup we have taken your launch clock path will be taken as the basically or late, and the capture clock path will be taken as early. Okay, so that is for the setup case, and hold will be the opposite. Hold will be the opposite. Then comes basically Musharraf Muhammad is asking which software is used for implementation of RTL to GDS flow. Okay, so we have couple of free softwares are there. For example, you have open source tools like OpenRoad is used for physical synthesis, and which is used for physical synthesis. Then there is another tool is also there. So there are two versions are there. Some commercial tools are there, some open source tools are. In case of commercial tool, you have Synopsys Design Compiler will help you to convert from RTL to gate level netlist. Then after you get the gate level netlist, then you can which is called the process of logic synthesis. From the gate level netlist to the layout level netlist, that is called the physical synthesis, which is used using IC compiler in case of Synopsys tool. And in case of Cadence tool, you have Janus. Janus will convert from RTL to gate level netlist, which is called the logic synthesis, and Innovus, which will convert from gate level netlist to the layout. So the Janus and Innovus are from the Cadence, and in open domain we have OpenRoad for physical synthesis. Okay, how can I send image? Pallavi is asking. There is no option to. You can ask in the discussion forum actually, not here. Okay. You can Pallavi. You can ask the questions in the discussion forum. Krishna Kumar is asking, can you please briefly explain about matching techniques and what are the things you need to take care of while doing it? Matching technique? Can you please elaborate what kind of matching technique you are talking about? Okay, this is the last question?
Yes, sir.
Okay. I have some questions. Can I present the screen? Screen, I don't know. I think sharing screen is not possible. Huh? Just hold on, we'll ask actually. So, for example, differential pair and current mirror. Okay. So you are talking about analog design. Okay. So in case of analog designing, what are the matching techniques are there? So usually they do the fingered layout. What is that called? ABBA kind of layout, but that is not covered in this course actually. Let's say you have one transistor. There is a ABBA like that. Is it visible? This
No,
is,
sir.
huh? Not visible. I'll do it in another paper over here. This is okay. I'll do it. Okay, just this is not related to physical design like this actually. So this one is one transistor. This is the same A transistor. This is B. This is B. So in case of a differential pair and all current mirrors, you have to AB. On those kind of techniques are used to average out the process variation. Okay.
For this, ask him to present in the, ask him to do in the discussion, like only chat message.
So here there is not screen sharing is not allowed. So you can write your question in the chat, Soham. Then comes Rishikesh. Can you arrange a session of interview preparation for physical design fresher role? It is what kind of interview session I should prepare. Basically, it is difficult to arrange some kind of interview preparation for physical design, but you can ask your questions, whatever doubts it comes to your mind after going through these lectures. We'll definitely answer through the discussion forum. Yeah. Then can you conduct a doubt solving session once a week on Sunday? Okay, we'll see how it is possible. Asking our NPTEL centers, but it is better if you can ask the doubts beforehand, because whenever or whatever it will be, basically is that we'll try to accommodate through your discussion forum. But if you have lot of questions, we can arrange one more live session. But it is better if you can ask all your questions before the live sessions begins. Then what will happen is that we can share those and answer actually. Okay. So then
I think question is.
no, that is done. That's done. So then, can you give some insight on the progress of AI ML in PDB? Yeah, it's very interesting. I was initially thinking to add this topic in case of in one of the week, but thing is that because of the time and all this, it takes a lot of time to basically cover the minimum required for the physical design. So we could not include that AIML in PD in this course actually. Okay, so nowadays there is a effort to improve and speed up the physical design using AIML. Yeah, that's correct.
Do you want him to talk?
Arun wants to talk. We cannot, but somebody asked actually, na?
But now I think it is disabled.
Huh? They disabled it.
Just ask him to post in
So,
this.
Arun, can you post your question in the chat? Arun, can you post your question in the chat? Okay, okay. So there is no more questions in the chat message. It was very good interaction with all of you, and going through the lectures. And if you have facing any kind of difficulty, please drop us an email.
You can explain.
This
If you
will take
want.
more time. We'll take 1 hour.
एक अनाउंस कर देंगे 5-10 मिनट्स आप कुछ और क्वेश्चन जनरल क्वेश्चन
Okay. So we have 5 more minutes left out for this live session. If you have any questions related to this, whatever the weeks we have studied covered so far, can you please write? If you have any doubts, please write, because 5 minutes left for this live session actually. This will take time. No? We'll reply separately. We are reading this much and solving. It's like problems actually. No?
This one is okay, sir. Assignments, it's related to assignment. I have clarified them in the discussion forum many times. And
Linear this.
linear ordering, that's
Huh? Linear ordering, they have some problem actually. Okay.
the explanation of
Oh, this is related to false packaging.
no, sir. That one combinational ST rise by form.
Okay. 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 What is the difference between abstract, frame, and design view of the physical design? Okay. So basically, the abstract view is a view whenever we have a any design. The abstract view will be uh, basically the metal one and above. Okay, the metal and below will not be covered in abstract view. And the frame and the cell view are the views which is created by your physical synthesis tool. Okay, frame view and the cell views are basically generated when you are creating those top level views. And the abstract view is metal and above, which we can use any kind of abstract generator tool actually. Let's say you have any kind of standard cells, then you can create its abstract view using abstract generator. And this abstract generator will the input the abstract generated will be going as input to your physical synthesis tool. Okay, since there is no more questions, we are almost going to close this live session, and feel free to ask us questions. We'll happy to answer those through discussion forum or through email. Okay, so hope you will basically understanding all these things whatever it is explained. WFX.
Hello, sir.
Hello. Hello.
So, from last 2 weeks, I'm busy in my placement. That's why, so I'm Gaurav Tale. I have taken your course,
Okay.
but from last 2 weeks, I'm busy in placements. That's why I'm not able to submit two assignments. Is there any chance to resubmit them?
There is reassignment submission is allowed. I don't know.
If due date is gone.
If the due date is over, then you cannot submit actually. It cannot be extended. Huh?
Focus on the next assignment.
Oh,
because
yeah, it is better. Don't miss the next assignment actually.
this will take best of 8. Best of 8.
That's to be
So correct. That there is a very good thing is that we will check the very best of 8 actually. Okay. So we have 12 weeks, we have 12 assignments will be there. So even if you left out 2 of them, basically we'll take the best of 8 actually. Okay.
Okay, thank you, sir. Okay.
We fix max. Urmi is asking, we fix max transistor in DFT also. Design for test, you insert the scan flops. What do you mean by max transition fix? I don't understand. Can you please elaborate?
Question and question mark.
Almost done actually.
How many
How many marks are required for the assignment?
Actually, each assignment is for 10 marks and it will be accounted for 25 marks in your 25% of your total score.
Okay, no? So there is no more questions. So we're closing this live session. Max transition in DRB in STA, as if we have max cap. Max transition in DRB. Can you please drop this mail? Urmi will try to answer through email. Okay, please write an email in a then we can discussion forum. Then we'll reply to your question queries actually. Okay, this Rudresh is asking, is there any rules in slicing floor plan? Yes, that is a very interesting question actually. There is no rules like means rules means what type of rule you want, how to create the slicing tree or anything else actually. Can you please elaborate? So can you explain? Dinesh is asking, can you please explain more problem in class? Complex problem. Okay, okay. Complex means NP hard problem we are talking about. NP hard, complex means yes. NP hard. I need to explain more problems. Okay, we can explain. So most of the problems in VLSI physical designs are NP hard. The reason is that let's say you are going for heuristic driven algorithm, let's say global routing. So or any kind of where we are using heuristic based method. The reason is that we are not able to get any kind of reasonable solution or any kind of deterministic solution in less time. So that's the reason most of the physical design problems are NP hard. However, we reduced it to some kind of special case algorithms to make it to solve it in the polynomial time. Okay. So then what is a virtual clock? Can you please, Urmi, you please ask all these questions in your discussion forum. Will reply. Okay. So I am training. Prasad is asking. I am in training in analog layout. Can I expect layout session? This is a VLSI physical design course. We will not do any training on layout because this is not an analog layout design course actually. Okay. Okay, so so with this we are basically closing this live session. Only by seeing the rectangular floor plan, how can I judge its slicing floor plan? Only by seeing the rectangular floor plan, how can I judge it is a slice? Okay, okay. You see whether it is cutting your bounding box into two parts, then it is a slicing. It divides. So let's say this is the bounding box. Okay. No,
1 minute.
sorry, sir. I'll draw it again.
Draw it on the same line.
This is the bounding box. Okay. Then if you have a partition like this, if you have a complete, it is dividing the bounding box into two different parts, two different partitions. Let's say this is A block. This is again we can divide into two parts, B, C also. So it is dividing. We have a complete. This is a horizontal cut actually. This is a horizontal cut, and this is a vertical cut. So that's why it is called a slicing floor plan, because it is just dividing the complete rectangle, this rectangle, into two parts completely. It is not partially dividing. So that's why it is called slicing. Like you have a mango, you are cutting it into two slices. Okay. Similarly, you are cutting the complete area into two slices. Okay. That's why slicing floor plan. Okay. Okay, with this we'll close the live session. Thank you for your questions. It is very nice interacting with you. Thank you.